Alright, so let's go for part 4 of our sets revision exercises. And, well, let's take a look at this. So I've got a universal set of all positive integers up to 10. So what would be U? It would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right? P seems to be just the prime numbers on this, just the prime numbers of the set. So it's 2, 3, 5, and 7. And Q seems to be the even numbers, but it's not taking 10 into consideration. There you go. So, letter A. Show these sets on a Venn diagram. Oh, let's use some room here. So, Venn diagram. First, draw your rectangle. That's going to be your universal set. So, how am I going to begin doing this? First, I'm going to draw one of my sets, right? And I will put the numbers in here, alright? And I'll choose how I'm going to sort them out based on some information that I know. So P, that's my set P. What's inside of P? 2, 3, 5, and 7. So 2, 3, 5, and 7. Now, let's look at sets Q. Does P and Q have anything in common? Well, they have this 2 in common, so they would have to share that element. That's the only thing that they have in common, by the way, isn't it? 4, 6, and 8, 3, 5, and 7, so that's the only thing that they have in common. What else do I have on set Q? 4, 6, and 8. Well, I'm just missing now what's left on my universal set. So what are the numbers up to 10, the positive integers up to 10, which are in neither of those sets? So 1, 9, and 10. And that's it. So, do we have all numbers up to 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There you go. So, Venn diagram, done. Now, list the elements. Oh, that's letter B. List the elements of P intersection Q. Well, P intersection Q is what they have in common. So, we have to look for this here. Okay? So, that's a set with only one element, 2. What about P union Q? So, intersection it basically means what both of them have at the same time. So, it would be analogous to our English word and. What does P and Q have? Both of them at the same time. Now, union means either. Right? So you're looking for anything that is in P or in Q. So you take into consideration everything which is in P and everything which is in Q. So 2, what else? 3, 4, 5, 6, 7, and 8. And that's it. It's basically all of the numbers except 1, 9, and 10, which are here in our universal set. Alright, what about Q prime? Now Q prime is our complement of Q. So it's basically everything which is outside of Q but inside of our universal set. So what do we have outside of Q here? 1, 3, 5, 7, 9, 10. Okay, so that's done. Now, letter C. Find the number of elements in complement of P. Now, if P has 4 elements and the universal set, take a look, the universal set has 10 elements. Set P has 4 elements. Therefore, set P prime would need to have 6 elements. However, you can also count. Take a look at your set P. If you're looking outside of set P, so everything which is outside of the blue circle here. How many elements do you have? 1, 2, 3, 4, 5, 6. So this is 6. You can do it either way. This is more elegant than counting. But anyway, you can pick your poison. Now, what about the number of elements in P intersection Q? So P intersection Q is what both of them have in common. Intersection is AND. So what do they have in common? 2. How many elements do I have there? 1. What about number of elements in P union Q? Well, P union Q is everything that they have combined. So I could do exactly the same thing that we have done here with a complement, right? The union, and then I can think, oh, outside would be the number of elements in our universal set minus that. But anyway, the union here, if you count, you'll see that it's 7, right? But you could also do, what I mean is, you could do the universal set minus those 3, which is outside, right? Which is basically the not. Okay? But don't worry too much about this. Now, letter D. True or false? The intersection of P and Q is a proper subset of P. Well, you might stop to think about this for a while. However, it's true. And it's always true, regardless of what sets you have. Because think of this. You're getting when you do the intersection of P and Q, this intersection will already be some P, some portion, some subset of P itself. In this case, it would just be 2, which is a subset, a proper subset of P. So that's true. The only situation in which this would not be true is if those sets were the same, and then you wouldn't have a proper subset. You would have actually the set itself, the set that you had in the beginning, to begin with. Right? So P intersection Q is always going to be P or less than P, is going to be P or some subset of P. So if Q and P are different, in the worst case scenario, you're going to get this to be empty. Right? And if this is empty, what happens? Well, if this is empty, you simply have your subset. Empty is one of the proper subsets of any set. So there we go, another one.